All right, Algebra 1 notes. So Algebra 1 notes. We're doing section 6.2, radicals and rational expressions. So you got to take notes. You got to copy everything down, just like I have it, and upload when you're done to get credit. You got to do it all though. It'd be good to put your name up here, the date, period, and this more on here. Okay. Put the title on it. Now, we've been doing exponents, so before we get into this new stuff, we'll kind of review some of the basics, and this is going to help. This will be kind of like a nice little cheat sheet note. Okay, so let's do a bunch of powers. 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, 8 squared, 9 squared, 10 squared, and let's see, 1 squared is 1, 2 squared is 4, 2 times 2, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36, 7 times 7 is 49, 8 times 8 is 64, 9 times 9 is 81, 10 times 10 is 100. You really should probably know those. You should probably be able to get those. But we also might need these. 1 cubed, 2 cubed, 3 cubed, 4 cubed, 5 cubed, 6 cubed, 7 cubed, 8 cubed, 9 cubed. Some of these are going to be a little harder, 10 cubed. Now, that's just 1 times 1 times 1, which is also 1 times 1 times an extra 1. So we could use our answers up here to help us. We just multiply that by an extra 1. We multiply this by an extra 2. 2 times 2 is 4, times 2 is 8. 3 to the third, that's 3 threes. We already did 3 times 3 is 9, times 3 is 27. 4 times 16 is 64. 5 times 25, 4 25s make 100, and you have an extra one, 125. 6 times 36, that might be a little hard now. We could use a calculator if we need to, or we could do it by hand. 6 times 6 is 36, carry the 3, 18 add 3 is 21, 216. 7 cubed, well, that'd be 7 times 49. Let's see if I can do it. 7 times 9 is 63, carry the 6, 7 times 4 is 28, add 6 is 34, 343. Or we could do it on our calculator. I mean, we could do 8 times 64, or we could do 8 times 8 times 8, or you could do 8 and the symbol we were talking about before is the caret symbol. So that's how you do power on your calculator. Now my calculator is a little different, but you could do this on your calculator too, similar calculator. So it's 512. I mean, I could also do 8 times 64 on the side if I wanted to. 8 times 4 is 32. Carry the 3. 8 times 6 is 48. Add 3 is 51. Right? 9 times 81. 9. 9 times 8 is 72. 729. 10 to the third, we should be able to do 10 times 100 is 100 with an extra 0 on it, 1,000. So let's keep those handy up there. But we are going to do some new stuff today. So I'm really just going to jump into some examples to kind of help us figure it out. So example 1, finding the real nth root. Nth root. So n meaning just kind of generically, we'll put a number there. So problem A is going to be n equals 3, a equals negative 27. So we're trying to find the nth root, the third root of a. So the way we can write that is we use something called a radical. So the nth root, the third root, we also call it the cube root, looks like this. We write it as like this little superscript number in front of this thing. This is called a radical. Okay, you might think of it as a square root symbol, but square roots are only one type of root. This is a cube root. So we're kind of trying to do what we were just doing though, but backwards, because this is asking you what three identical numbers multiply times each other to give you negative 27. So we're trying to take these answers and go backwards. So we could write it. I mean, you could look up here. 27 came from 3 times 3 times 3, but there's a negative, so it's going to be negative 3 times negative 3 times negative 3. So we could rewrite it like that. And this came from negative 27 came from negative 3 being cubed. The answer is negative 3. So the root, we call this a root, is the number that you raised to this power that gave you this answer. I'm working backwards. So let's do another one of these. N equals 4, A equals 16. So the first thing we're going to do is rewrite it in this form with radical. So this is the fourth root of 16. So we're asking, what I raise to the fourth power, what I multiply 4 of, and get 16. So you could go up here and say, well, there's 16, that's 4 times 4, but we need 4 things multiplying each other. So you might think, oh, 4 is 2 times 2. Like this is 2 times 2 times 2 times 2. And so the answer is 2. But watch out. There is another possible answer that could be the fourth root of 16. We could do negative 2 times negative 2 times negative 2 times negative 2, because if you have 4 negatives and they multiply each other, it becomes a positive, right? This could also work. So negative 2 is also an answer. Now, what we usually do, when you take, so in the book, we'd write that as plus or minus 2. Just together, you can write it as kind of like a sort of a condensed version. So, okay, now I want you to try some problems. So I'm going to write some down. This will be C. N equals 3, A equals negative 125, and then D, N equals 6, and A equals 64. Okay, so pause the video and try these two problems. And then unpause it, check your answer, and then we're going to do some more examples. So, assuming you guys have tried it, pause the video and tried it, now you're back. The first thing you do is rewrite this as the third root, or the cube root of negative 125. And you got to think, well, what do I multiply times? That 3 numbers times itself, that would give you negative 125. You look up here. So, oh, that would be 5. That's going to be negative 5 to get negative, right? So the answer is negative 5. Okay, how about this one? This would be the 6th root of 64. Oh my goodness. Now, I mean, just guessing, it's got to be a bunch of numbers, but it's got to be small because it's going to get big quick. Like if you go up here, 64 was 8 times 8, right? And 8 is 2 times 2 times 2. So if you think of this as 8 times 8, well, then that would also be 2 times 2 times 2, and 2 times 2 times 2, and that's perfect. That's 6 2s. Now, we could also have had all negatives in here, so we're going to do plus or minus. Okay? Now, the plus or minus is only on these problems where we wrote it like this, because I'm going to show you some problems that are a little different next, and those ones, you don't do the plus or minus unless it says it or it comes from a different situation. So here's example 2. Directions will be evaluate each expression. So we're going to be doing the same kind of stuff, but we're going to start to write it. The problems are going to be already written with radical. Okay? So cube root of negative 8, we're doing the same work. Negative 2 times negative 2 times negative 2 is what will give you negative 8, right? So the answer is going to be negative 2. B, negative cube root of 8. Now this one's a little different. The negative's on the outside. That makes a difference. A negative on the outside is the same thing as a negative 1 times the thing it's in front of. So we're really just kind of ignoring, the negative is just over here on the side, and then we're saying, okay, well, what would we multiply times itself 3 times? That would give you 8. And so then that's going to be 2, and your final answer is going to be negative 2. Okay, C, 16 to the 1/4. Now, this is a little different. This is called a rational exponent. Rational is a fancy word for, rational is kind of fancy for ratio, which is fancy for fraction. So a rational exponent is an exponent that's a fraction. What's in it, though, is a couple different things, okay? The bottom is going to be the root. The top is just going to be a regular power. So we're going to rewrite it, the root, that's the 4th root. So we'd write that as 4th root of 16, okay? And then the 1, we just raise on the outside afterwards. So the bottom is the root. Down low stays low. Up high stays high. So we got to figure out, what do you multiply times itself? 4 times 2 times 2 times 2. I mean, you could think in your head, well, it's 4 times 4. And 4 could be 2 times 2, 2 times 2, so perfect. And then you raise it to, so it's going to be 2, and you raise it to the first power, it's going to be 2 when you're done. Okay? Now, here's another one. Let's see. Negative 16 to the 1/4 power. So this is going to be the 4th root of negative 16 to the first power. Now, this one's kind of a strange one, because what would you multiply times itself? You know, you might think, oh, that's going to be like 2, negative 2 times negative 2 times negative 2 times negative 2. That would give you 16, right? But it would be positive. Like, what number can you multiply times itself 4 times that would end up giving you a negative? It's not possible. It's not possible. So they say not a real number. Now, they say not real because there are these things called imaginary numbers that come from this kind of problem. But you're not going to learn about that until Algebra 2, which is after geometry, so a couple years down the road. Okay? So let's try a few more examples. Call this example 3. We're going to evaluate. We're just going to make them a little tougher. Okay? So, little tougher. Things are going to get a little more interesting. 16 to the 3/4. That's a radical, or that's a rational exponent. Now, the thing on the bottom is the root. The thing on the top is just regular old power. So when you rewrite it, you do the 4th root of 16, and then you do the 3rd power afterwards. Okay? So the thing on the bottom is the root. The top is just regular exponent, but you want to do that afterwards. So then you're saying, okay, well, what's the 4th root of 16? Well, okay, well, that's 2 times 2 times 2 times 2. And after a while, you guys are going to start to just be able to do these quickly in your head. So that's going to be a 2. But then we got to cube it. 2 times 2 is 4 times 2 is 8. That's your final answer. 16 3/4 is 8. Turned out kind of nice, kind of weird looking. Okay, B, 27 to the 4/3. So this is going to be the cube root of 27. The denominator is the root, and then we're going to raise to the 4th power afterwards. So what do you multiply time? It's going to be what? 3 times 3 times 3. So that's going to be 3 to the 4th power. It's going to be kind of big. 3 times 3 is 9, times 3 is 27, times 3 is 81. Now, you could go ahead and use your calculator. Don't use it on all of these because you're just not going to learn how to do this. But we could do 3 to the 4th power, right? Or 3 times 3 times 3 times 3. If it's a big number, okay, you can do it. All right, last one's for you to try. So I want you to try this. The directions are going to be evaluate. And the first one is going to be the cube root of negative 125. The second one is going to be negative 64 to the 2/3. That one sounds crazy. And the third one is going to be 9 to the 5/2. So I want you to write those down, pause the video, and try them yourself. Okay? Okay, so we're trying to figure out, what do you multiply times itself 3 times to give you negative 125? If you look up there, that was 5, but it's got to be negative, so it's going to be negative 5, negative 5, negative 5. And so the answer is going to be negative 5. All right? This one we're going to rewrite negative 64 to the 3rd root raised to the 2nd power. So cube root. What do you multiply times itself 3 times? I think it's going to be 4, right? Negative 4 times negative 4 times negative 4. So it's going to be negative 4. And then you're going to square it. And it's going to give you 16. Positive 16. Okay, last one. Square root, 2nd root of 9 to the 5th power. So what do you times itself to get 9? Well, that's 3 times 3. That's the square root. So it's going to be 3 to the 5th. Now 3 to the 5th is going to be a really big number, right? I mean, we could try and work it out on our calculator or on paper. We do that. It's 243. We could do 3 to the 5th on our calculator, 243. So it's going to be 243. So now, hopefully, look over your notes. Make sure you kind of understand this. For our classwork, we're going to be doing monitoring progress. This is in the book. This is on page 300. Number 1 through 6 all, not a whole lot of them. Write the problems down, show your work, get the answers. Now, these ones are at the bottom of each page in section 6.2. And if you're zoomed all the way out, there's a blue arrow that if you click on will show a video of exactly how to do each one of these problems beginning to end. So there's no reason to get them wrong. If you're getting stuck, you're not sure, watch the videos. And then make sure to upload your notes, okay? And then also upload your monitoring progress with all your work. Make sure your name's on it. Make sure it's labeled, page number, problem numbers, box your answers, okay? So there you go. Let's get it done.